days. Okay, evolutes and involutes are not that studied, and therefore I got this particular note from a very old book, and that I shared with you. I don't know why evolute and involute has been uh, retained in this particular course curriculum, BSM 101. It is not actually required and it's not useful also. I do not find any use of that. I haven't found, maybe it is my fault, but I haven't found any use of this in information technology. I don't know. Maybe people they want you to know want to know whether you have some basic idea about curves and etc. or all. That is the only logic which I can say. Now, the discussion, the note is starting from the discussion of curvature. Probably you have seen curvature. And radius of curvature was defined. And after that, the radius of curvature was defined. Just a minute, hold on a second. Sorry for the interruption. Another class is going on over there. So I had to close the door. Otherwise, the noise is actually disturbing me. So probably you have seen that the curvature was, the note started with curvature, and then radius of curvature was defined. Probably you have seen it, or if you have not gone through, I'm just telling you that the radius of curvature was defined, and after that, uh, after a few pages, center of curvature was defined. Okay, now this evolute, this particular part is actually related to center of curvature. Involute is also related to center of curvature. So if you don't so I actually wanted to show you that the starting point is not evolute. Evolute comes very later, once you know about curvature, radius of curvature, and then you will get to see what is center of curvature, and then you'll get to know what is evolute and involute. But you don't have to study everything. You don't have to do problems on radius of curvature, because it is not needed according to our syllabus. We shall only concentrate on this particular portion. I can discuss the thing very briefly, what radius of curvature is. Very briefly I can discuss. So let us talk about radius of curvature. What is the thing, what is it all about? So suppose I am drawing a curve like this. Suppose this is my curve. Okay, this curve is fx. This is not a curve, it's a portion of the curve I have drawn. And suppose I am choosing two points from there. Suppose this is the point which I am naming as capital. This is the point which I am naming as capital P, and that is the point which I am naming as capital Q. These 2 points look very much, I mean, close to one another. And then what I can do, I can draw a tangent. I can draw a tangent through these 2 points. So let us try to do a tangent from to these 2 points. So this is one of the tangents, and this tangent, and let us do another. Let us draw another tangent through the point Q. So I'm drawing another tangent over there. Now you see that the length, this part, this PQ, what is it? This PQ is actually the arc of the, a very small arc of the curve, a very small arc of the curve, and I'm considering the length of PQ, the length of PQ to be delta S. If S is the arc length, delta S is the length of the PQ, the small arc. Now, this tangent at P is making angle psi, and this tangent is making angle psi plus delta psi. Okay, so we can very well understand that this particular angle will be delta psi. Now, what will happen? Question is, what will happen when P tends to Q, or Q tends to P? What will happen then? So if this is so, this happens, then the the tangent, the angle, there will be some change in the angle. There will be some change in the angle. So that you will see that we are going to find, actually we are interested in finding the change in arc length with respect to the change in the angle which the tangents are making with the positive direction of x-axis. Okay, so we are interested in the ratio delta s by delta psi. Okay, and when P tends to Q, that means, this implies that this delta s, this arc length, is actually diminishing. So we want to know limit delta s tends to 0, delta s by delta psi. We want to know this. That is the thing which we study in radius of curvature. Okay, and we know very well that limit delta s tends to 0, delta s by delta psi, this is equal to ds d psi, or dd psi of s. Now this particular thing, we can call it as the rate of change of the rate of change of the curve, the rate of change of the curve with respect to the arc. This is called the rate of change of curve with respect to the arc. Okay, in a word, we can actually, we want to know this particular thing we get from here is to know that how a particular curve curves. Okay, when we draw a curve, what is the nature of the curve, how it curves actually? That is actually that is actually studied in radius of curvature. So this is not the radius of curvature, remember, this is just the rate of change of the curve with respect to the arc. Now what is radius of curvature? The radius of curvature is defined in the following manner: the reciprocal of the curvature, the reciprocal of the curvature at any point P, is called the radius of curvature. The reciprocal of the curvature at any point P is called the radius of curvature, and it is denoted by rho, which is defined as rate of change of arc with respect to the angle. Rate of change of no, one thing I have actually written wrong. Sorry for this. because the wrong was, the thing is that actually I started with what will happen when P tends to Q. So when P tends to Q, when P tends to Q, we are actually interested in, we are actually interested in knowing that the arc length will diminish. So as I have written, you have not noticed it, limit delta s tends to 0, so there delta s must be over here and delta psi must be over there. So that thing should be, I just written the opposite, sorry for this. So this will be d psi ds, change of, change rate of change of angle with respect to, with respect to the arc length, rate of change of angle with respect to the arc length. That is your, that is this thing, particular thing. Okay, and radius of curvature will be just opposite to that. Radius of curvature will be ds by d psi. That is your radius of curvature. Now in this particular after this you will get to see that in this, in the note, some formula for finding radius of curvature has been mentioned, but we shall, I'm not going to discuss this, this thing will not be required. You can skip all this formula for radius of curvature for your current scenario. We are not dealing with radius of curvature, we actually deals with center of curvature. So we shall move on to, we shall jump on to center of curvature, because we, our job is to study evolute and involute. So we shall not discuss what radius of curvature is. So in page number 319 you will get to see that center of curvature has been defined. Okay, so let us write the formula for the center of curvature first of all. And probably you are thinking that these things, radius of curvature and center of curvature, these things are actually very new to us, but it is not actually so. But center of curvature you have seen, center of curvature, radius of curvature you have seen earlier in some other chapter with some other names. Okay, so if we have a curve that, this curve actually curves in a specific manner, then to a particular point, with respect to a particular point capital P, there must exist another point Q. And we'll say that if I draw a normal from this point Q to point P, if I draw a normal like this, then we'll say that capital Q is the center of curvature with respect to the point P. In this particular, I'm not writing many things, I'm just writing it briefly. Q is the center of curvature. Q is the center of curvature with respect to the point capital P. Now, if you consider another point P1 over here, and suppose you draw a normal like this, and suppose this point is Q prime, the Q prime will be the center of curvature with respect to the point P1, and so on. You are going to get several center of curvatures with respect to several different points situated on the arcs of the curve. Okay, and the coordinates of the center of curvature is in general defined by a formula is given. So let me write the formula. So if I denote the coordinates by x bar y bar, okay, if I denote the coordinates by x bar y bar, so x bar is actually x minus y1 1 plus y1 square by y2, and y bar is equal to y minus 1 plus y plus 1 plus y1 square by y2, and here y1 is dy dx and y2 is d2y dx2. Okay, this is the formula for finding center of curvature. So if you ask me that where have you seen this center of curvature earlier that you are talking about, I will say that yes, you have seen center of curvature earlier in the coordinate geometry. So if you consider a circle of this form, if this is the circle and this is your center C, now you know that a circle is a kind of locus of a point which moves in a certain way, so that it is having a constant distance from a fixed point C. So we call this distance to be your radius R. Then in case of circle, your center of curvature is nothing but the center of the circle. Okay, and radius of curvature is nothing but the radius of the circle. Center of curvature and radius of curvature are nothing but the center of the circle and radius of the circle. Okay, and you see, if you take any point, if you take any point, say P prime, P double prime, P triple prime. So you see, if you draw a normal from here, that is also R. If you draw a normal from there, that is also R. If you draw a normal from there, that is also R. If you draw a normal from there, that is also R, because it is a circle. That's why it is happening. But for any arbitrary curve, that is not going to happen. If you draw different points, different normals will be obtained. Okay, so this is the formula in general for the center of curvature with respect to any arbitrary point pxy. Okay, now what is evolute? What is evolute? So you see that in the next phase, in one of the chapters, the evolute is defined as follows. Why you are probably thinking that why center of curvature is needed. So because in the definition of evolute, the center of curvature is there. So evolute is defined in the following way: the locus of the center of curvature, the locus of the center of curvature of a given curve, is called its evolute. And what is involute? What is involute? Involute is if the evolute itself be regarded as the original curve, a curve of which it is the evolute, is called an involute. Okay, so what does it mean? It means that, suppose you carefully try to understand these definitions. Center of curvature is there. Now you are doing what you are actually seeing over here. The center of curvature, in place of circle, it is C. Now if you are actually moving, if you actually want to know the path of this center of curvature, how it is moving, this path, we actually denote this by locus. And if this locus is obtained, if you find the center of curvature and this locus is obtained, then this locus will give you the evolute of the curve. What is the curve over here? The curve over here is the circle. Now if sometimes for some curves, it so happens that if I try to find the path of the circle, if I try to find the path of the center of the circle, what happens is that the locus of the center is takes in such a way, it actually considers the path in such a way that the original curve is obtained. Okay, the locus of the center of curvature is becomes the original curve. That now that original curve to which this evolute has been considered, that original curve in that particular case will be known as the involute. So you can consider, to begin with, you can consider an example of a circle. Say for example, because you are all familiar with circles, and you can write x square plus y square is equal to a square. A is the radius, a is the radius of the circle, and the circle is situated, the circle center is at the point 0 0. The circle center is at the point 0 0. Okay, this is your circle. Now what you can do, suppose you do not know that it is a circle, so we can write it as y square is equal to s square minus x square, and we can try to find, this is my curve, and we can try to find, you can try to find the center of curvature in this particular case. Okay, you do not know, we know from our previous experience that it is a circle. Suppose this curve is not known to you, you do not know what is it, and then you are I have actually asked you to find the center of curvature. Now try to find center of curvature. So what will you do? Let x bar, y bar be the center of curvature, be the center of curvature of this curve, center of curvature of this curve. Okay, now if you consider this, if you consider this, and then in this particular case you will see that for plus root over s square minus x square, you are going to get this upper half, and for minus root over s square minus x square, you are going to get this lower half. Okay, so you are going to apply this result, this formula for x bar and y bar, and try to find out, it is, I'm going to giving you to you as a home task, that try to find out what are the coordinates of x bar, what are the coordinates x bar in this particular case, and what are the coordinates y bar in this particular case. It's I'm giving this particular problem as a homework to you. Okay, you try to do it by yourself. I'm not going to do it because see, this calculation, I mean, is this see, so several derivatives have to be considered, several things have to be, see, you are going to calculate the derivatives, and then we are going to put it over here. It's very simple. Dy dx, you find dy dx, and then you find d2y dx2, and put it over there. I am just telling you what evolute and involute is. Okay, so you try to do it by yourself, and then once you find this x bar y bar, so x bar will be in terms of x and y bar will be in terms of y. To try to find this locus of this particular center of curvatures is are known. Try to find an equation with respect to x bar and y bar only. Try to express x with respect to x bar and y with respect to y bar. You are going to get x bar with respect to x and y bar with respect to y. Then the same way you actually found did in geometry, coordinate geometry course, try to express x with respect to x bar and y with respect to y bar. Then you will find the locus of this center of curvature, and that will be your evolute. Now if you find that your evolute is actually becoming the circle itself, then that circle is actually the involute. Okay, so your job is to find what you need to do. This is step number one. So your job is, let x bar y bar be the center of curvature of this curve, then find what is x bar and what is y bar. Okay, and step number two is try to express an equation in terms of, or try to not express, try to find an equation in terms of, x bar and y bar. Okay, which will be the locus of the center of curvature. That will be termed as the locus of the center of curvature. Now the point is, your conclusion will be that locus will be actually known as evolute. The equation which will be obtained, which you will obtain, will be called evolute. But if you find during the process, after the calculation, if you find a kind of thing like this, x bar plus y, x bar square plus y bar squared equal to s squared, if you find a thing like this, so that is also a circle's equation. So your evolute becoming the circle itself, then the circle will be called the involute. If it is not in this, if it is in this form, but if it is not, the locus is not in this form, then the original curve, that is the circle, will not be termed as involute. Let me give you another problem. You try all these problems at home, because it's a matter of taking the derivatives and putting things and finding. I'm not finding it any interesting. So you have this in your syllabus, you do it by yourself. Another example I'm going to give it to you, that this is find, all these things are actually known to you. You need to do the calculations only, which you can do by yourself very well, I think. So find the center of curvature at any point. Find the center of curvature at any point x comma y on the parabola, y square is equal to 4ax. Okay, and if you face any difficulties, you can ask me later on. So this is another question I'm giving, and it has another part. Find, just similar to the previous one, find the evolute of the parabola. Find the evolute of the parabola y squared is equal to 4ax. Then you can deal the thing with by taking an equation of ellipse also. You can do this kind of, you can do the same calculation with respect to an ellipse if you want to see. Okay, and another example I'm giving, if you do these three examples, I think you will understand that how to center of curvature of the following curve, that is x square by s square plus y square by b square is equal to 1, and also find the evolute of this curve. I have given you only the known problems. No. Who said? Abhinav Pal. Why are you confused? Highlighted portions. I told you that highlighted portions, these are highlighted for, I didn't highlight these portions. They were highlighted. Who told you that the highlighted portions are only your syllabus? You have got this wrong notion. How did you got this wrong notion that highlighted portions are only the syllabus? Who told you that? The entire syllabus, BSM 101, is your syllabus. What is this? After so many days, you are asking me that only highlighted portions are the syllabus. In the very beginning, I can recall that one of the students asked me that, sir, why these portions are highlighted? Some portions were highlighted. I told you that previously we used to share this particular syllabus. So the syllabus were divided in this particular manner. The one teacher will take this portion, another teacher will take that portion. Now probably two teachers they shared this thing in a particular semester, so they have divided this, they could have probably might have divided these sections in this particular manner with the highlighted portions. I got this particular thing from a source. I have got it from, I didn't download it, I got it from somewhere. No, you shouldn't. You could have asked. Now the examination is knocking at the door, and now you are asking me that why this highlighted portions or not. Entire syllabus, be starting from module 1 to module 5, everything is there in the syllabus. Everything. And that's why I am taking the calculus portion with the CSEB, and I am continuing another portion with CSE section A, so that I can finish the syllabus from both the directions. Major portion of the syllabus is linear algebra, that you can say. 70% of the syllabus is linear algebra. Module 3, module 4, module 5. Module 2 consists of this mean value theorems, L'Hospital's rules, and in the next class I'm going to do the extremization problem. Module 1 containing this evolute and indefinite integral beta gamma function. I'm going to send those notes to you. And some, I think one surface volume of revolution, like this kind of thing was there. Since I do not have time, because the exam suddenly we have been thrust with the examination. Examination was not supposed to happen at this point. Initially it was thought to happen in the end of March. I thought so, but suddenly somehow university has changed decision, and they have set a deadline from 12 to 26. So I am in a hurry, because you can see that the way I teach, way I used to teach in the classroom, this way is not being followed. You can see me, you can see my face, that I'm in a kind of hurry to finish the syllabus, because I am also helpless. I could have done all these problems for you, but I cannot, because you have to help me. I'm just sending you notes. You do the calculations by yourself. Otherwise, I'll not be able to finish the syllabus. At least I have to officially declare that okay, I have discussed everything. Okay, so that's why, that is the thing. I am just helping you out. I'm not doing the calculations. Calculation will just kill time. I am just showing you the algorithm by which you can proceed. I have given a very simple problems to you. The known curves. One curve is the circle, another curve is the parabola, another curve is the ellipse. I think if you do these three problems, you will understand what is evolute and involute. Okay, evolute. So you have to remember the steps. I'm again writing. To find the evolute, step number 1, take the curve, whatever curve is given to you, find the center of curvature. Your center of curvature will represent another curve, definitely. Okay. No, sorry, this line I have to rectify this line. First of all, you find the center of curvature. Finding center of curvature means find coordinates of the center of curvature. When I say that find center of curvature, that means I'm asking you to find the coordinates of the center of curvature. Step number 2 is that find locus of the center of curvature. Find the locus of this. Now, locus of the center of curvature will be a curve. It will be another curve. Okay, that locus will be another curve, and that curve will be known as evolute. Evolute of the original curve. Okay, and step number 3 is, if you see that the curve represented by the locus is the original curve, itself, then the original curve will be called involute. If the locus of the center of the circle is the circle itself, then the center of the circle is the locus of the center of the circle is evolute, and the original curve from which the evolute has been found, that is that circle itself, will be called its involute. If the locus of the parabola, locus of the center of curvature of the parabola is a curve which is other than the parabola, something else, then that curve is called evolute. But if you see that the locus of the center of curvature of the parabola is the parabola itself, then the original parabola will be called its involute. Similar is the case with that ellipse. That is the thing, you have to keep this mind. If you have to keep this mind, this particular algorithm is in mind. This is a kind of algorithm I am talking about. You remember this and you will understand what I am talking about. Try to solve these three problems, you will understand everything. So I am actually discontinuing at this particular point. We shall again meet in the next week, and we be prepared for your Sunday examination. Okay, we shall meet on Sunday. So till then, bye.